and float, type of float and its application. Next, I need to give the introduction about the critical path method. So here the path, which means that a connected sequence of the n number of activities leading to one start event and ending event. So in the network, so for draw the network, there are different types of paths. While I'm drawing, I will explain what are the different paths. So out of this path, the connected sequence of the activities will be considered as a path. In that, critical path is the longest path, which means that more time duration, which considered as a project duration, that is known as a critical path. So critical activities, which means that all the activities that make up with the critical path. So here I will explain all in one small network. So example, so I will draw a network. So this is the network which connecting n number of activities. So here one network like this. So for the activities, here A, B, C, D and E. So these are the one network. F and G. So let us assume these are one network which consider one starting event and one ending event. Here, the path, which means that there are three different paths. One is A, C, D is an one path, and also B, E is an another path. Then F and G. For example, this is G activity. F and G is the another path. This is considered as a critical, this is considered as a different path. In that critical path means if we add the duration of this all activities, so we have considered that what is the maximum duration, that is known as a critical path. So for example, this is the maximum duration, that is 8 weeks. For example, it is 8 weeks means A, C, D is a longest path which has maximum duration, which is considered as a critical path. So the critical activities which means that what are the activities presented in the path A, C and D. So A, C and D are the critical activities. So in the critical path method, I have explained what is the path for a network, how to make a path, and critical path is maximum duration and the longest path, and critical activities associated in that critical path. So now we have to do the estimation of the time. So to make the critical path method, the first thing is we want to estimate the time. So this time estimate will be considered as a two aspects. One is forward pass, which is earliest start time and the earliest finish time. The other one is the backward pass. So that is the next slide. Backward pass is the latest start time and the latest finish time. So for a simple activity, I will mark the earliest start time and the latest. Only these two activities, then we directly go to the problem. So here A and B is the activity. So which consumes a duration of two. Another activity also I will made it like a longitudinal sequence of that activity. So A, B, C are the activities which having a duration of 2 months and 3 months and again 2 months. So now forward pass and backward pass I need to draw. The forward pass, which is like this forward from A to C. So for that, the condition is earliest time of activity can start with the precedent activities which completed first. So earliest start time is the starting duration. Earliest finish time will be the equal to earliest start of that activity plus duration of that activity. So here earliest start time and earliest finish time. So earliest start time is the starting duration. That is, there is no predecessor for this. So we have to mention the 0 is the earliest start time. Plus earliest finish time is equal to earliest finish time equal to earliest start time plus duration. So earliest finish time plus duration. So earliest finish time is equal to earliest finish time is equal to earliest start time plus duration. D is equal to duration. So coming to here for B activity, what is the earliest start time? Earliest start time will be earliest finish time of the preceding activity, that is A. So earliest finish time of preceding activity is 2. So 2 plus at earliest finish time is and earliest start time plus duration. 2 plus 3, 5. This is the earliest start time of B, earliest finish time of B. Then coming to the C activity, earliest start time is the earliest finish time of preceding activity, that is 5. Plus duration of that earliest finish time plus duration, 5 plus 2, 7. So now the forward pass is completed. So next is the backward pass. So backward pass, which is like this. Here, latest finish time will come first. Then minus duration, we will get the latest start time. So coming to here, the latest finish time will be, then forward pass, there is another condition I will explain in the next problem. So backward pass, the first is the latest finish time I need to add. So the latest finish time is equal to 7. So minus duration, which is equal to 5. Okay. So here 3 and 4. So here for activity B, the latest finish time equal to latest start time of succeeding activity, that is 5 minus the duration, latest start time equal to latest finish time minus duration 2. So similarly, here the latest finish time of A equal to latest start time of B, that is 2. The latest start time equal to latest finish time minus duration, 2 minus 2, 0. So this is a one longitudinal sequence network. How we can find the earliest start time, earliest finish time, latest start time and latest